Okay, we have discussed about point load at the center on a simply supported beam. Now we are discussing about point loads at the end of a cantilever beam. A cantilever beam is something which is fixed at one end and it is free on the other end. Okay, so this cantilever beam is of length L, is fixed at point A, and it is free. Its free end is B, where I have applied a load of W, point load of W. Now, how to draw the BMD and SFD for this? So first of all, you need to find the reaction. So for a cantilever beam with point loads, always the reaction will be equal to sum of all the forces. So you need to find the force here, and that will be equal to the reaction here, right? So here I have only one force, so W, and this will be Ra. Now for drawing the shear force, I'll use the same method that I used for drawing the shear force of simply supported beam. So I'll start from left end. So at left end I have reaction which is in upward direction. So here I'll draw a line which is proportionate to W, and between A and B there are no loads or no points. So I will draw a straight line like this, and at B I have load of W in downward direction. So I will draw a line like this. So this is my shear force diagram, right? It is just a simple rectangle. Now coming to the bending moment diagram, in case of simply supported beam, at the supports I had bending moment equal to 0, correct? Now in case of cantilever beam, the bending moment at the free end will be 0, whereas the bending moment at the support will be maximum. Now here I have only one point load at the end of the cantilever. So the bending moment at this point will be equal to load into perpendicular distance. So this is W into L. So this value will be W into L, and here it will be 0. In between there is nothing, so I join it by a straight line like this. So I get a triangle shaped bending moment diagram. So the bending moment is varying linearly. Okay, so the very good example for cantilever beam is your electric poles or the light poles, right? You see any lamp post or electric poles, the thickness of the pole at the support or at the ground where it is fixed to the ground is considerably larger as compared to the thickness at the end, right? The main reason is the bending moment at the support is maximum, and at the tip where the load is being applied is equal to 0. But I cannot make a zero tipped lamp post or electric pole. That's why we have some thickness for making the fixture put in place properly, right? Otherwise, if you see, it is tapered like this. The thickness at the bottom is much larger as compared to the thickness at the top, right? So this is about SFD and BMD of a cantilever beam with concentrated load at its end.